This is the problem. To plant a seed, you have to dig up the soil. But to grow the seed, the soil has to be in good nick. And if you dig up the soil to plant the seed, then the soil won't be in as good a nick as if you didn't dig up the soil. But if you don't dig up the soil, then you can't plant the seed. After a while, it does your head in.
My attitude to the land is that we're a custodian to the land, and we need to ensure that we leave the soil in a better state than when we got it. In tilling the soil, we had simple equipment that would allow us to be able to pass through the soil in order to place the seed in the soil.
Hard as hell under there.
The disadvantage of that, of course, is that we've ruined the soil structure. And in that process, we had to think long and hard about what we were doing to the two most important elements that we deal with, and that's soil and water. And we only saw back in the 70s and 60s the amount of erosion that we were losing purely and simply because we were continually farming the soil. We've got a number of factors that are forcing us to look at higher yields. And we've got the huge issue of food security and population pressure, with estimated 9 billion people on this planet by 2050. So in order to remain profitable and in order to remain competitive, we've had to look at the fact that one machine needs to be able to do more than one job.
Ross came to me with this idea. It was a difficult concept because we didn't have the technology to offer Ross to make this happen.
We had the dream that we wanted to have a machine that was truly multi-purpose, and we saw a need to be able to open soil and place the seed in the soil using different soil opening techniques. But we also saw a need to have the apparatus be able to continue to farm conventionally.
So let's have a look at some different soil opening techniques. Please welcome Ross Hubbard and Richard Sulman.
You've combined a number of different elements in here that are quite innovative in farming terms. Can you tell us a little bit about them?
What we've created is 3 separate mechanisms that allow us to essentially ground follow. So as the machine passes through the soil, we want to apply seed at a consistent depth. And why we want to do that is so we optimise yield.
Well, let's have a look at it in action, Ross. Fire us up.
Okay, so Ross is adjusting the parallelogram, and that mechanism there is the ability for the unit to follow the ground contour, and so that seed can keep at a consistent depth. So this is one mechanism. The second mechanism that Ross is going to show is a breakout ability. So it actually can automatically break over obstacles in the soil.
This is the stump chunk.
That's the stump chunk.
Yep.
So that would be being done because a log's hit it or
yes,
stones
exactly.
hit it. It wouldn't be operating it.
Yes, and what's novel about this mechanism is the combination of 2 well-established mechanisms in agriculture, but have never been joined together. And that was done by introducing a third element into this system, the press wheel. And it will automatically have a predetermined force placed on that press wheel, which creates the pressure around the soil. And of course that soil pressure against seed again gives you the needed soil contact for good germination.
Fantastic. That's a great display. Now let's have a look at what it would look like in the paddock and show people what that would look like.
What we're doing here is seeding into a heavy blanket of wheat residue so that we can conserve moisture, because at the end of the day the most compelling thing is the saving of the moisture so that we can grow the crop. For years we were complaining about how dry it is, now we're complaining about how the floods have affected us, but the reality is that that's just the world we live in. Yep. And what we've got to do is we've got to have a tool that is truly multifunctional.
And we used to use our hands, actually, guys, if you feel out of this, because it's a prerequisite to shut your finger off to work in agriculture like that. So. But anyway,
it is convincing hundreds of young kids right now, Chris.
OH&S is fine.
The interesting thing here is that you've taken an 1870 invention, the stump jump, and you've suddenly improved it, which is fantastic. But you've also got 3 elements here which you can put on one machine quite easily. You've already talked about the seeding, which you've got the seeder and you've got a boot here for seed, you have another boot for fertiliser?
Yes, you can put another boot behind that for fertiliser, either either liquid fertiliser or solid fertiliser.
And Richard, this gadget here, this turns it, you just fit that onto the same spot as you did have your boot before.
That's right.
And all of a sudden you're now doing a cultivator on the same, expensive piece of machinery.
And this is one of the key aspects of this design, is that it's now enabled a multi-function tool to exist. So you can have one machine in the shed, which would take the place of possibly 3.
How much extra weight does all this extra ability to change things add to your plough?
It doesn't add a lot of extra weight to it, James. And
in terms of fuel efficiency as well?
Horsepower? Horsepower requirements depend on the depth with which you're seeding. We've been seeding some crops as shallow as 12 millimetres, small seeds, grass seeds, where the horsepower requirement is down to no more than 2 or 3 horsepower per opener.
Look, farmers are just looking for efficiency. That's the goal today in farming. So you've managed to pull together all these factors and deliver a range of different efficiencies. So congratulations.
Thanks very much.
Thank you.
Thank you.